Okay, so the first problem here is, or I guess two problems, Unit 10, question 2 and 3, which ask what would be a good buffer system to use if you want a solution with pH of 4.3. So part A, you use the Henderson-Hasselbalch equation to find the pKa and Ka of the system when they're equal concentrations of conjugate pairs, so that's pretty easy. Here the Henderson-Hasselbalch equation, pH equals pKa plus log of your concentration of base over concentration of acid. However, we know base and acid are in equal concentrations, so this would be 1, and log of 1 is always 0, so we can just get rid of that term. And we're left here with pH equals pKa. We know the pH is supposed to be 4.3, so 4.3 equals pKa, which means 4.3 equals negative log of Ka. To get rid of that, we do 10 to the negative 4.3 equals Ka, and then you get a Ka of 5.012 times 10 to the negative 5th. The pKa then, pKa, since it asks for pKa and Ka, your pKa is 4.3, your Ka is 5.012 times 10 to the negative 5th. So that's part A. Part B, it asks you to use your Ka chart to choose an acid that you could actually use for this. So we know your Ka is 5.012 times 10 to the negative 5th. So on your Ka chart, you want to look here for everything that has times 10 to the negative 5th. I'll go through and circle them. There's one all the way down here too. Okay, and then after that we want to see which one is closest to 5.012. So 1.8, not really close, 8, not really close, 1.5, not really close, 1.9, not super close. Let's see. I think I missed a couple, yes, here. Benzoic. Yeah, okay, so benzoic acid is the closest at 6.3 here. There's also, back page. Tartaric acid here has 4.6 times 10 to the negative 5th, but that's Ka2. So since there are two Kas, we don't really want to mess around with that. So the best option that we have is benzoic acid here at 6.3 times 10 to the negative 5th. All the others are 1.8, 1.5, something like that. So for B, we're going to choose benzoic acid Ka 6.3 times 10 to the negative 5th. That's going to be your best choice. Now for number 3, it asks use the buffer system you chose. So using a buffer system with benzoic acid, what would be the ratio of base to acid that is needed for the pH to be exactly 4.3? So in this case, again, we're just going to use the Henderson-Hasselbalch because we know the pH. We know the pH we want. We know the Ka, so we have pKa. Here, wait, I'll just write it down. So we know pH, we want 4.3. pKa is just negative log of Ka, which we now know because we chose benzoic acid. And then the question is asking us for this ratio here, ratio of base to acid. So we'll just have to get rid of this log at the end. But that'll be pretty simple to do. So here, 4.3, this ends up being 4.201 plus log concentration base to acid. Keep solving through. 0.09934 is log of base to acid. So then to get rid of this log here, 10 raised to the 0.09934 is our ratio. And so then we just solve for this. Ends up being 1.26 equals the ratio here. And that's all it was asking for. So then this 1.26 is our final answer.